All right, welcome back. Unit 10, we're going to do surface area, a lot of surface area, volume, three-dimensional figures, all right? A lot of notes first section. I apologize. I'm trying to get it to more succinct later on. First of all, we need to talk about what are the figures we're dealing with in 10.1. First one's going to be called a prism. A prism is a polyhedron, a three-dimensional figure with two congruent parallel sides called bases. The other sides are called lateral faces. All right, so there's two sides that are bases. Some prisms are going to be harder to see which side are the bases because lots of sides could be bases. But most of the time, prisms you're going to see. This is a base because it's the same. It's a pentagon, and it's the same pentagon as this bottom. In fact, we call prisms by their base shape. So this is a pentagon base, so it's a pentagonal prism, all right? So these bases are connected with these faces, and we call them lateral faces. And this is a lateral edge. It connects the two bases together and is one side of a lateral face. Over here you can see this is a triangular prism because it has triangles as its bases. All right. Now, a couple of things. First thing is, sometimes it's real great when these shapes are like this, bases on top and bottom. But sometimes we can turn them around here too. All right. The bases could be actually on the sides. All right. Not everything's nice and neat in math, so you have to figure out where the bases are. All right. It's not as hard as I'm probably making it out to be. All right, so let's talk a little bit more about these bases. The altitude of a prism. The altitude of a prism is the perpendicular segment that joins the planes of the bases. It's the height of the prism is the length of the altitude. So this edge here is the height. It is the perpendicular distance from one base to the other. Perpendicular distance from one base to the other. Notice when the height is a lateral edge, we call these right prisms. In other words, when they are perfectly straight up and down, all right, they meet perpendicularly, we call those right prisms because they have those right angles. But prisms can also be called oblique. I like to think of the Leaning Tower of Pisa when I think of oblique prisms or things like that. It's like they lean, they're just shifted over a little bit, all right? And it's still, the height is still going to be the perpendicular distance there. We're going to work mostly with right prisms, but every now and again we're going to talk about oblique prisms, all right? All right, so like I said, a right prism is when the lateral faces are rectangles and a lateral edge is the altitude, all right? That edge is actually the altitude. And unless you are told otherwise, always assume for our purposes that any prism is a right prism. I will tell you otherwise if it's oblique. The other way you'll know it's oblique because the lateral faces are non-rectangular. Look at this. Every face here is a rectangle. This little one in here, it's a smaller rectangle, but it's still a rectangle. These are not rectangles. Yes, they're quadrilaterals, but they're not rectangles. All right? But again, most of the time right now, we're just going to be dealing with right prisms. So let's take a look. What I've done here is we want to find the lateral area. So the lateral area is all these sides. I want to find the area of this side and add it together with the area of this side, all the lateral sides, and add it together with the area of this side, and add it together with the area of this side. The only thing I don't care about, I don't want to find the area of this base or this base, all right? And you can see I've kind of unfolded this. When I unfold this, this is the base that we don't want to, that we're not looking to find right now. This is the other base that we're looking to not find right now. So if you look at this, this lateral area is right here. And what could we describe this lateral area as? Well, it's a rectangle. All right? It's a rectangle. We just unfolded that shape, made a net, and made a rectangle. Now, this is 4, followed by this side is 3, followed by this side is 4, followed by this side is 3. That's just the perimeter of what? It's the perimeter of the base. All right, so the length of this rectangle is just the perimeter of the base, right? And the width of our rectangle is right here. It's our altitude. It's our height. So we can find this lateral area by just multiplying the perimeter of the base times the height. And if it sounds like a formula, ladies and gentlemen, it probably is. So the lateral area of a right prism is perimeter times height. And remember, this perimeter is the perimeter of the base. All right? We'll talk more about that in a second. We'll do one. Now let's take a look here. Well, if we have found all this right here, we found the area of all this, we only have two more sides to cover the entire thing. All right? And surface area is the sum of the lateral area and the two bases. So the lateral area we know how to get, and then we're going to add the two bases. So lateral area plus two bases. Well, let's take a look. Lateral area plus two bases. That's what it is. Now, check this out. Right now, it's pretty nice. We have two rectangles, right? Two rectangles right here. Could these shapes change? Yes. Notice this. This is lateral area plus the area of two bases. This big B stands for the area of the base. Now we have a lot of different area formulas, all right? We have the area of a rectangle. This one is length times width. We have the area of a triangle. We have the area of lots of different shapes. So this formula could change quite a bit. But in general, what we're going to have is our surface area will be the perimeter times the height, which is just our lateral area formula, plus 2 times the area of the base. And again, that base formula will change depending upon what our figure is. All right, let's try one. So find the lateral and surface areas of the following prism. So first thing we need to do, find the lateral area. And what is our lateral area formula? Perimeter of the base times the height. So I need the perimeter of the base. So I have 3 plus 4 plus, man, I don't know what that is. But it's a right triangle, so I know I can use Pythagorean theorem to find it. Now, this one, some of you are jumping out of your seats right now going, I know the answer, I know the answer. And if you do, great, because this is one of the all-time big ones, right? If you don't, remember you can do a squared plus b squared equals c squared. And then we get 9 plus 16 equals x squared. 25 equals x squared. And then x equals 5. So this side here would be 5. So now we know our perimeter is 3 plus 4 is 7. Plus 5 is 12. All right, now we need to find the height. And again, the height connects the two bases together. What is our height in this case? It is 6. So multiply it out. 12 times 6 is 72. And we got units here. We got centimeters. Now, anytime we're in area, what kind of unit do we have? We have squared units, right? So the lateral area of this is 72 square centimeters. All right? So now let's find the surface area. The surface area is the lateral area plus 2 times the area of the base. Well, we know the lateral area. That's nice. 72 plus 2 times the area of the base. What base do we have? We have a triangle. What's the formula for the area of a triangle? 1/2 base times height. Now, I know this gets confusing. We got a base here, we got a base here. That's why I kind of did this as a big B. Big B means area of the base. Now I'm looking at that base, and this triangle formula has base times height. Remember, our base and height are perpendicular in triangles. So the base here would be 3. So this is going to be 2 times 1/2 times 3 times 4. All right? Plus 72. Okay? Nice thing about this, 2 times 1/2, that's just gone. 3 times 4 is 12. 72 plus 12 is 84 centimeters squared. All right? So that right there, now we have found the area, a lateral area, and the surface area of a prism. All right. Next one, cylinder. A cylinder is another solid that has two congruent parallel bases that are circles. This time it's very specific. It's not. It's like a prism except for the bases are circles. All right. So our bases are circles here and here. Again, right cylinders that perpendicular distance is perfectly straight up and down. Oblique this is exactly like the Leaning Tower of Pisa. It's leaning over a bit, so our perpendicular distance is not exactly that side length right there. All right, so let's find one. Oh, let's take a look at these formulas. Here we go. Now I've kind of unwrapped this. You got to kind of imagine. Now, if you have a hard time imagining this, actually get a toilet paper roll, cut it, and unroll it. You're going to see that what you have is a rectangle when you unroll that. All right. Now, what is this rectangle? Well, this is the area, the cut you made. All right. And this here, this 2 pi r, what is 2 pi r? 2 pi r is circumference. So I'm just unwrapping the circumference of this circle, and that is our width, right? So length times width. Okay, if you want to find lateral area right here, it's just going to be 2 pi r times h. And that sounds like a formula, and it is. 2 pi r times h. That is our lateral area. All this right here, our lateral area, 2 pi r times h. And that's because we rolled that out. All right? Surface area then, we know what the nice thing about surface area with cylinders is you know what the formula for is every time. It's the same actually as a prism. 2 times b, but we know what the area of b is. We know the area of a circle is pi r squared. So our surface area formula, we could even write it out specific every time. We could write the length, the lateral area is 2 pi r h plus the 2 times the area of the base, pi r squared. All right, so let's try one of these. Okay. So, find the lateral and surface area of the cylinder. Here we go. Let's find the lateral area. So, lateral area equals 2 pi RH. So, 2 pi, what is R? What is our radius? If our diameter is 10, our radius has to be 5. And our H connects the two bases together, so that's got to be 12. 2 times 5 is 10. 10 times 12 is 120 pi meters squared. All right. Surface area. So surface area is the lateral area plus 2 times our base area of the base, and it's pi r squared. So we know this is 120 pi. 2 pi times our radius again was 5, and 5 squared. So 120 pi plus 2 pi times 25. So that gives us 120 pi plus 50 pi, and that is 170 pi meters squared. All right. So that's finding the surface area of the cylinder. All right, so let's try some more examples here. Let's find the surface area of each figure. Now the great thing here, surface area, when we find surface area, we're finding lateral area already in it. So let's do this. This is a 1, 2, 3, 4 pentagonal, a regular pentagonal prism. Regular because all the sides are the same. So surface area equals perimeter times height, that's the lateral area, plus 2 times the area of the base. What's the area formula for the base of a regular hexagon? 1/2 times the apothem times the perimeter. All right. All right, right off the bat, I'm just going to 2 times a half cancels out. All right, let's just take care of that right now. So, perimeter, I have to add all the sides up. 7, 7, 7, 7, 7. So, 35 times my height is 9, plus the apothem is 4.8 times the perimeter, and again, we know is 35. All right. We multiply this out. We get 315 plus 168. Add those together and we get 483 inches squared. All right, so you got to remember this formula too. I'll provide you with the formula sheet. I'm not going to tell you what formula to use though. All right, I'll probably say these are area formulas. You need to recognize which ones you have to use. All right, so now round to the nearest tenth. So nearest tenth, that would be 483.0. All right, over here, surface area of a cylinder. So we got 2 pi r h plus 2 times the area of the base, which is pi r squared. All right, so let's plug in what we know. Our radius is, if our diameter is 20, our radius is 10. Our height is 8 plus 2 times pi times our radius again squared. So 2 times 10 times 8 is 160 pi plus 10 squared is 100. 100 times 2 is 200 pi. Add those together and we get 360 pi. Now remember, this is the exact answer. It's exact because pi is one of those irrational numbers we cannot, we can round and guesstimate with it, but we cannot get exact. If I plug in 3.14 for it, it's not going to be the exact same thing. So now, when I say round to the nearest tenth, I'm going to be using the calculator's approximation. All right? So let's take a look at what I mean. So I want to do 360 pi. So let's go to our calculator. 360 pi. Our pi symbol is right here above the exponent button. So if I have to get to the blue, I have to press second. Then I can press that right there, the pi button. Now this is going to give me my decimal approximation. I'm using this value of pi. I don't want you to put 360 times 3.14 in. I want you to do it this way so all of us have the same answer. All right? Because I want to make sure you guys know how to round as well. Here's why. So we want to round to the nearest tenth. So I go, here's my tenth. I look before. 7 rounds that 9 to what? A 0. Ooh, that means I have to round this up to a 1. So this is actually going to be 1,131.0. All right? 1,131.0 in kilometers squared. Holy cow. That's a huge cylinder. Probably not real life right there. Kilometers are really big, right? All right, so pause the video. Just kidding. Let's watch Mr. Kelly. Let's do a little application. Sullivan has become tired of all the bullying from Mr. Kelly during his videos. One day he catches him and starts to lower him into a vat of acid. He tells him the only way he can save himself is if he correctly figures out the square feet of paint that Sully used to paint the outside of the vat. Vat has a diameter of 6 feet and is 10 feet deep. Kelly guesses 30 square feet. Will he survive? Let's take a look. So we want surface area, right? Now surface area is lateral area plus 2 bases. But check this out. If we're dipping him in, do we have 2 bases? No, we're missing a base. So ours is really going to be just base. So what's our lateral area? 2 pi r(h) plus the area of our base is going to be pi r squared. Let's take a look. Our radius, if the diameter is 6 feet, our radius is 3. Our height is 10 plus radius squared is going to be 3 squared is 9, right? So 2 times 3 times 10 is 60 pi plus 9 pi. So that's going to be 69 pi feet squared. Now he said 30 feet. This is already 69 times 3 is way more than 30 feet. So is Kelly's going to survive? Of course not. Dip him in, Sullivan. Boom. That's what you get for all those funny pictures and videos making fun of Sullivan. Alright, now you try some on your own. Pause the video and work them out. Alright, welcome back. So these are kind of good because I think there's a little trick here on the one. Let's find the surface area. So surface area equals 2 pi RH plus pi r squared. 2 pi times the radius is 3 times the height is 8 plus r squared is 3 squared. So that's going to be 9, right? So that's 9 pi. 3 times 2 is 6. 48 pi plus 9 pi. Oh, I forgot this. Times 2. Yeah. So 18 pi. Alright. And 48 plus 18 is going to give us 66 pi feet squared. That would be the exact answer. If we wanted to approximate it, we plug it in into our calculator and round it up. Alright, now this one's tricky. This is a rectangular prism. Rectangular prisms are tricky because this could be the bases, these two sides, right? Or the front two sides, the front and the back could be the bases. Or the top and the bottom. It all really depends, alright? So here's what I'm going to do. I'm going to say these two sides are my bases. If you didn't use those two sides, you should still get the same answer. So let's take a look. If that's 8, this is 8, this is 8, and 8. Alright, so surface area equals the perimeter times the height plus 2 times, what's our formula for finding the area of the base on this? Length times width, right? So what is the perimeter of the base? 8 times 4 is 32, times the height, the length that connects them is 10, plus 2 times length times width, 8 times 8. 32 times 10 is going to give us 320. 2 times 8 times 8 is going to give us 128. Add them together and we get 448 centimeters squared. Alright, there you have it. I know today's video is a little bit long, lots of vocabulary. It's going to get easier as we go on, alright? We're going to find lots of different shapes and surface area and volume and lateral area and all these fun stuff. Best of luck on the mastery check. Welcome back, Mr. Sullivan. Woohoo!